Hey all, we are going to have a live online deep dive session on a specific topic of internet networking. And this session is totally free. For the topic, for the timing, please click the link below and register. In this short video, we are going to talk about cabling standards and naming convention. For Ethernet, over a period of 40-50 years, there are a lot of changes, there are a lot of evolutions that has actually happened, which actually which actually asked for some of the cabling standards and naming conventions. There are few drivers that actually drive these cabling standards and naming conventions, and we are going to talk about that very briefly in this video. The first thing is the media type. So depending on the speed, depending on the medium, there are broadly two different types of media types. One is optical and another is copper. We'll dive deeper into each of these in a bit, but one of the driving factors is media type. The second most important driving factor for the naming conventions and standards is the speed. We started with 10 Mbps in one of our previous videos. We already saw this. We started with 10 Mbps speed, then we moved to 800 gig, and then to now we are talking about 1.4 terabits in an Ethernet link. And what demands this much amount of speed is, in today's AI world, there are a lot of inference clusters which is actually demanding for low latency and high speed, and that's why and that's one of the use cases where such a huge speed is getting demanded. But whatever is a use case, understand media after media type, speed is one of the things that is actually driving to have a specific standards, and the speed will be incorporated when somebody has a naming convention, and we will see that. And finally is the length. We may start with 100 meters to all the way 500 or 5 kilometers or 5,000 meters. Also, you will be able to see some of the standards like which ends with SR, which is short range, and something ends with LR, which is long range, which actually talks about what is the speed, what is the distance that can be covered by this set of cable types. So to sum up, it's a media type, speed, and the length that is actually driving these standards. A little bit more on the media type. So we talked about the copper. So for the copper, we are actually using the unshielded twisted pair. Most of you guys might have seen this type of cable, but again here what it uses is the electrical signals to send the traffic. And the benefit and the characteristics of unshielded twisted pair, which is for the copper, is the short distance, and it is actually less expensive. We'll have a separate video just talking about this unshielded twisted pair. We will be talking more about how the pinouts are, what is each color in the unshielded twisted pair stands for. We'll go over that in another video. But for the fiber optics, for the light, again, what happens in the fiber optics is we are using light as a resource to send the signals in the physical layer. For that, characteristics are, it is a longer distance, can be covered with a longer distance, it can be more expensive as well. Now coming on to the standards, again, this is a standard, just a brief standard that we got from the CCNA 200-301 official cert guidebook. If you see, starting at the speed at 10 Mbps, and the common name for that is the Ethernet. It is also called as 10 base T. It is that, and when you hear 10 base T, what you need to remember is it is a copper, is a medium type, and the distance that it can cover is 100 meters, and the speed is 10 Mbps. And another standard is the fast Ethernet, which is 100 Mbps. It is called as 100 base T. When you hear 100 base T, what you need to remember the media type is copper, the distance it can cover is 100, and the speed is 100 Mbps. Also, you'll hear something about gigabit Ethernet. The name is 1000 base LX. What that means is it is a fiber, and which means it can cover 5,000 meters, and it can carry 1000 Mbps. Finally, there is another 1000 Mbps, but it is called as 10 base T. You see the difference at the T and LX. T T is nothing but the copper, Lx is the fiber, but the other things remains the same. Also, since it is copper, you can see the distance that can be covered, the length that can be covered is only 100 meters and not 5,000 meters as opposed to the fiber. And finally, it is there is another thing called 10 Gbps, and it is copper, and the standard name there for that is 10 G base T. Now we have covered only 10 to 10 Mbps to 10 Gbps here, but do remember that, as I mentioned in the previous slide, there is standard which is up to 1 terabyte and 1.4 terabits itself. So the standards always evolves, but whenever you see something like this, what you need to remember is what it is trying to say. When you hear 10 base T or anything of that sort, what it is trying to tell you is what is the speed it can have, what is the medium that it can actually send a signal, and what is the length of it. Now, where it is significant, let's say there is a device. When you build a device, they will be having the Ethernet ports, which again we have discussed in one of the earlier videos. And you're having those, you cannot put a fiber cable into a copper port. So if you're building a device, you need to make sure that the device ports are built in such a way that the copper only the copper type of devices goes to the copper ports, and only the fiber type of cable will be going to the fiber ports. So that's where the relevance of why you need to know about the standard comes in, because when you architect, when you design a network which is at the data center, what you need to remember about is what is the speed requirement, and for that speed requirement you need to have the correct devices in your data center. Once you have the devices, you should make sure you are having the right standards, cables with the right standards for the type of design that you are actually looking for. That was a quick brief. Again, we will dive deeper in upcoming lectures. Thank you.